So I hope you understood the database design for Book My Show, which we discussed in the last class. That was the most complicated booking app. Book My Show is the most complicated booking app. Any questions on that?
Yeah, in the database driven design, we applied till third normal form only. The Boyce-Codd normal form, can you explain here?
Okay, sure. We'll do that. Boyce-Codd normal form is the stricter version of third normal form. Right? So it states that, every non-trivial functional dependency must be dependent on a super key. This is BCNF. Great. So let me elaborate on this. Yes, this is looking like some other language, right? So BCNF. Let me give an example. So assume you have a few fields. One is, let's say student. So this is, so first column is student ID. Second column is course ID. Okay, this table is not that good. Okay, let me add here some other table with my drawing. So you have here, first column is, assume we have student ID. Second column, course ID. And the last column is, say, professor, right? You will have values also. Here you have values, say 101. Course ID, you may have, say, CS001. This is the course. And then you have a professor, say, Mr. X, right? He is the professor. Correct. So let's have few more columns, few more rows. So maybe similarly you have course 102. You have course, say CS, maybe let's say 0011. And then Mr. or Y, Professor Y. These are your. So if you have a table design like this, what would be the primary key? Which uniquely determines this particular row in the table. Yeah, you should understand here, there are three entities. One is a student, right? So other one is course. So what kind of relationship is there in student to course? Tell me the cardinalities of this relationship. Who will tell? Who knows? Whether it's one-on-one, many-to-many, many-to-one, what kind of relationship is it?
Many-to-many.
Can a student take multiple course?
Yes.
Right? Perfect. Yeah, correct. Awesome. Absolutely right. It will be many-to-many. And a course can have multiple students. Then you have another entity, which is professor. Right? What kind of relationship is there? Right? Can a professor take multiple courses? right? Yeah, that's possible because you will have a professor taking multiple courses. A course will be headed by a single professor. So this is many to one because we don't allow, basically professor is the HOD or he's the head for the course. So he will be grading it. So the course ID is probably a subject. So here you will have always one professor for a particular course, but a professor may take multiple courses, but each and every course will have only one professor. Clear? This relationship is clear? Right. So then what does it mean? It means that you may have a course. You may have, say, maybe a student who has taken some other course also. Let's say this course is 2-1, right? And this course is also headed by Mr. X. Is this a valid table? Right? You have same students taking another course, and Mr. X is the professor. Now tell me what will be the primary key for this table?
A combination of student and course ID.
Right, absolutely, because you may have another student also who will take this course, and then the professor is also there. Do you see a problem in this table?
But as per second normal form, the professor may not depend on student.
Professor may not depend on
Student.
Okay. So what is second normal form? In normal form?
The non-key attribute should
Yes.
depend on primary.
Right. Absolutely. Right. So this is data is fully functionally dependent on the primary key. Right. Yes, and in the same way, here you have a concept of super key. Basically, this is very similar to the second normal form, but here we have a concept of a super key because the primary key is combination of student ID and course ID. Yes. So professor ID should also depend on this combination, but which is not the case. So here you have to split this table. How can you split this to become normalized?
Student, course and professor.
Yes, absolutely right. Correct. So this is what we have in the BCNF. Right. So the only concept difference is here you have a concept of a super key, means multiple keys are here. You see student ID is definitely not the primary key. Primary key is the student ID and course ID together. Right. If here it would have been, say, I will give a difference between second normal form and BCNF. let me give an example of second normal form. So this is for BCNF. Second normal form is slightly different, not much different, but it is different. It is talking about a primary key, and all the non-key primary keys should be functionally dependent on the primary key. So here assume you have order ID. Then you have, let's say, product. And then you have customer. Right? And then, yes, a customer will have multiple details. So customer name. And then let's say we have also one more column, which is customer ID. No, customer address, right? So here, primary key, what is primary? Only order ID. There's no super key, right? Super key, this is your primary key or your, right? This is a super key because it has multiple columns. But here in this case, there is only one column. See, order ID, say for example, 001 may have some product, say product could be iPhone, right? 14. And there could be a name, right? Say, right? And there could be some address, right? So maybe addresses, right? So something, some address could be there. And some address is there. So here, an order. So product is dependent on order ID because every product, and because product is a part of an order. And customer is also someone who is ordering. But customer address is not dependent on the order ID. So this is violation of second normal form. So how do you fix this?
Remove from this table.
Pardon?
See what we, yeah, what can we do is, in the customer name only, we can change it as customer details and put the name and address together.
Okay, so let me draw this. So how would you put customer name and details together? So for
In
example,
one column only, we can mention, right?
one column. Okay, in one column only you mention
Customer details.
customer details. Okay, and you have everything here. Right, so this you call it customer details. Right, and then you keep the other columns same. Correct. So what do you feel? Others,
Oh,
is
we
this
need to,
design better or worse?
no, it violates first normal form.
Right? See, yeah, because see here, the problem is you won't be able to search properly, right? It always involves text searching. If suppose I want to give orders for the name, customer name Srinivas, this string could be thousands of characters, right? So it will be very difficult to search for this particular customer Srinivas. So this violates definitely the first normal form. So this is not helping. So the way, better way to design it, yeah. Anyone has some suggestion?
We need to create separate table with the customer name and the customer ID, name and address columns.
Right? Yes, yes. Right. So here the, instead of putting customer name here, you use another table. And in this table, you have the customer details. So you can put so here customer ID and then other details, which is customer name and customer address. Right. So you have an association, which is a foreign key relationship here. So this 1 and 1. So you can find the name of this customer. And here the address would be there. Right. So this is about the second normal form. So yeah, we saw also the table where first normal form is not satisfied. Yeah. First normal form states that every column should contain only one kind of value. Second normal form says that all other keys should depend on the primary key. In mathematical terms, they say functional dependency. So second normal form, let me write the statement about second normal form. So let me talk about, say, yeah, here we are writing here. So I'll put at the top first normal form. What is first normal form? Each column contains atomic data, only one value. This is first normal. Second normal form.
It should depend on the primary key.
Data, yes, all the data is fully functionally dependent on the primary key. So this is second normal form. I'm writing 2NF. Yes, that should be clear. And third normal form, who will tell about the third normal form?
Transitive dependency.
Absolutely right. Third normal form is
No transitive dependency, correct?
transitive dependency. Yes. Great. So you're seeing the screen, right? Properly? Great. So yes, let's consider some example of transitive dependency so that you understand this. Anyone knows what is transitive dependency?
No, if A depends on B and B depends on C, that is called transitive dependency.
Yes, absolutely right. Perfect. Yes. So yeah, there are different ways of speaking here. So say, just a minute, let me think about some good example which can demonstrate. about this transitive dependencies. Right. So here, let me give an example, something similar. So you have a table, let's say third normal form. Yes, you have a table. And in this, we have again few columns. Let's put at least 3 columns you need or 4 columns you need to demonstrate transitive dependencies. First is your student ID, right? Let me write because so first column is a student ID. Second column is course ID. Like this, be small. Then you have say course name. Yes. So here, student ID and course ID forms the primary key, correct? Because as we discussed in the previous example also, where is this one? This is similar here, right? And then here you have the course name also. And then you have the professor also. So definitely course name is dependent on course ID. Professor is also dependent on the course ID. Yes. Professor is not dependent on the student ID. So this is an example where you have
So Tarun,
yes.
in the third normal form, we shouldn't have this dependency, right? That is what it says, no transitive dependency, correct?
Yes, yes. Right. So yes, here the transitive dependency means student ID is course ID is dependent on student ID, and then these are the transitive dependencies. So in this case, you have to break down this table into, basically here, actually, I don't need this. This is only required in BCNF, but here there is no transitive dependency required here. There should not be any transitive dependency. So that means you should break it down into 2 tables where you have student ID and this. So this is about third normal form. Right. Basically, it comes by intuition, actually. You don't have to go into that detail. So here, course ID, right? Basically. And you have course ID and course name. Yes. So this is the third normal form. So better you split this into these 2 tables. So to get the third normal form. So basically you have to create a foreign key relationship. So this is your foreign key. Course ID is a foreign key and student ID is your primary key. And definitely your foreign key is a primary key of another table. So that is the definition of foreign key. So course ID is for a primary key of the course table and student ID is the primary key of a student table. So these are various normal forms. Let me also discuss about there is another normal form, which is the fourth normal form. So that fourth normal form, anyone having idea what is fourth normal form? No idea? Fourth normal form says no multi-valued dependencies. Now, what does this mean? No multi-valued dependency. Let me think of some example about fourth normal form and what do you mean by no multi-valued dependency? Yeah, let me think of, say, yes, let's consider a few relationships. So here, let's say we have a relationship here, which is, yeah, let me draw again a table. So let's see here, what is multi-valued dependency? So here you have a student, right? A student ID. There can be a course ID. And there can be textbook, right? Textbook or, yeah. Why I'm taking this example? Because professor can only be associated with a single course. But a textbook may be used for any number of courses, right? So basically the relationship is You have a student, you have course. So this we know is intact. Many students can be there in one course. And a course can have many students. Textbooks, what about textbook? Same. A course may have many textbooks. Fair enough, yes. And there could be a textbook could be applicable in many courses. This is, let's call it book. So this is the relationship. Right? So here the problem is, given a course ID and a student ID, there could be multiple textbooks which could be there, right? Say, this is a problem. So here, let's say CS 101, you have some book, let's say, let us see as a book, right? By Yashwant Kanedkar, this one book, right? So there is another book, say here. This is again for this course, CS 101. This is, say, Dennis Ritchie. So, programming in C. Okay. So, this is another book. But yeah, student ID is the same. So here you have the dependency, here multi-valued dependency. Here you have multiple values on the keys. So this is a multi-valued dependency. Again, you have to break it up so that it do not have multi-valued dependency. How will you break it up? Yeah, always. When you have 3 columns, then you will always break it up with. So here, course ID is the kind of a foreign key which will be associating both of them. So you'll have here a table which is course ID and book. And then you have here student ID and course ID. This is how you will resolve this dependency. Don't need to worry about exactly sharing the normal form, but you should be aware that these are the problems which may occur in the database design, and wherever there is duplication of data, you have to resolve it. So basically, everything is about dependencies from first normal form. First normal form is atomic data, or every column should contain atomic data. Second normal form, primary key, is about primary key. Basically, you can, if you have table which is not having any primary key, that means you cannot determine uniquely a table, a row, then that is a problem in the table design. Third normal form is all about having a foreign key relationship. So whenever you have transitive dependencies, better to break it down using foreign key. Yes.
Tarun. So the third normal form says that no transitive dependencies, correct?
Yes.
Yeah. Okay.
Yeah. It is no transitive dependency. And I should use the term no here rather than, yes, I just saying transitive dependencies. Right. So yeah, I forgot this to say no transitive dependent. No is very important. Yes. Correct. Right. Right. So this is all about the normalization, right? So all the four normalization, normal form. So now let me take another topic, because we will proceed with the design of Book My Show. So anyway, I said to you just now before, discussing this query, that Book My Show is the most complex booking app, right? Why did I said, right? What are other booking app? IRCTC. Yeah, IRCTC is also complex, but yes, not as that complex, because yeah, there could be complication if you have to do the reservation, train reservation, right? Because in that you have to put the starting destination and ending destination. But yes, if you just leave this IRCTC, hotel booking app, flight booking app, bus ticket, bus always is from start destination to end. Assume you have to book from start to end the bus ticket. So these kind of are less complex, because in movie ticket booking, Book My Show, or I would say movie ticket booking, they are complex because same seat could be assigned to multiple shows, right? So we created a show seat, concept of a show sheet. This is how we were able to deal with multiple shows in a hall ticket, and a person can book multiple shows also and seats. Other application, hotel booking, you will always book a room for a particular date. There's no partial booking allowed. Same is the case with flight booking. So you don't need any additional entity like show sheet. In bus ticket also, you don't need any additional entity like bus ticket. Yes. So we discussed the database design. And as I said, there are multiple designs you should be able to give. We also discussed a kind of algorithm to do the booking, because I said if multiple users are booking a particular ticket, so what you have to do, you have to lock the table first. And after locking the table, you have to request the payment. There should be a timeout, which is 10 minutes or 15 minutes. If the payment is successful within that 10 minutes time, you confirm the booking. If the payment do not happen in 10 minutes time, you cancel the, or you release the seat and do not allow it to be booked. What if the payment happens after 10 minutes time? What you will do? Any suggestion? What happens in Book My Show if you block a ticket, but you do not pay, but you pay after 10 minutes?
Actually, you're saying that when we start booking and we left it open for 10 minutes.
Yes.
Then because there will be time, right? Like 7 minutes, 8 minutes will be there.
Yes.
After that, I think it will be, others can do that, book that.
Right. Others can book that. So assume the scenario is you chose a seat. Yes. And you start clicking on the pay button. And then you are entering your credit card details. It took you, say, 9 minutes to fill up all your credit card detail. Timeout is there for 10 minutes. Then at 9th minute, you initiated the payment. The payment gateway took 2-minute payment request. At the 11th minute, your money is deducted, right? Although it started before 10 minutes. So the payment happened, payment started, but payment was not confirmed till 10 minutes. And so what would have happened is the ticket would have been booked by someone else, right? How do you deal with this scenario? So assume in that time, another person also booked that ticket. So will it not be 2 users with the same ticket, same seat? For the first one, yeah, go ahead.
So there is one status column, right? Once we initiate that, it will still be processing until that status is failed or completed. We will not proceed further. Can we do like that? Or if the user even after the 9 minute, like after the 9 minute, the user is still like initiating, we will continue locking that database and not database table.
So yeah, you have to consider various scenarios here. So one scenario is maybe the payment happens in 2 minutes. Other scenario is maybe the payment did not happen in next 10 minutes also. So in that case, you will keep blocking the seat. And maybe after 10 minutes, you got a cancellation failure. So you are blocking the seat for more than 10 minutes, which is bad. Just give me a minute. So yes, solution is, in case the booking takes more than 10 minutes, release the seat. If the payment is confirmed, refund the money for the user. Automatically initiate the refund process. This is what happens in Book My Show or any other app, even in the flight booking app also. Right? Because sometimes in flight booking, they will send you an email that we will confirm you the payment status. In case the flight is booked by someone else, you will get the refund. So initiate the automatic refund in this case. Right? Because you're not sure when the payment will happen. So at 10th minute, you only know the payment has not happened. So all these scenarios you have to take care of while designing any booking app. So maybe, yes, in some classes, we will discuss the design of IRCTC, how to ensure that you are able to book tickets and reserve the seat. And again, the same seat can be reserved in multiple combinations from start station to end station. So again, same seat can be booked by one passenger from station A to station B. And then from station B to station C, some other passenger can book and so on. So we'll discuss that in some other class. But yes, let's discuss other parts of the system design. So having given the database design, next thing what you can do is you can give the API design for Book My Show. Yeah. Right? How would you design an API? Basically, you have to think of that, okay, you would have a backend server and then you have multiple clients. In case of Book My Show, maybe you have a mobile client, which could be Android and iOS app. And there could be another client, which is web client, right? See, you have basically multiple teams who will be working on your APIs and they will be calling the backend service. Backend service will be writing the data to the database. So this is basically, we have a 3-tier architecture here, right? So architecture is, you have a backend server will take care of. We may have multiple services, we'll see. But yes, how will you design the API? Any suggestions for API? So one API could be, you have the function get movies. Yeah. What should it return? It should return list of movies. Yes. And what should be the input here in movie?
City.
String.
Right?
City.
City would be the input. Yes. So maybe this is a string city, right? you may also need the date, right? Or by default, you can assume that, okay, if I'm calling this, then it is about today, right? Or yeah, but yes, you may want to check the for tomorrow also, right? Maybe if there are 3 days, then you may take an integer input, 0 meaning to today, 1 meaning tomorrow, 2 meaning day after tomorrow, right? Do not support previous dates, right? Because it will be invalid. You cannot book ticket in the past. So no use of searching previous date, right? So you have to ensure validation, proper validation. Date should be in future, today or future date, right? Maybe you would also need the time, right? So let's call this date time. Yes. Right? Because you may need the show, you may enter show timing also. It depends on how you would like to design. What do you think? Time we should allow or only date is good enough? Yeah, for simplicity, let's say only date. Time anyway, we will give and user can choose it, but maybe user may not be allowed to search with the time. Fair enough. It's our design. And in case required, you can discuss with the interviewer and design it, right? So this is basically, yeah, you don't have to write the code for this. You just have to give the API design. This is one design. It will return movies. Movie will contain, you will have movie ID. Yeah. It will be basically retrieved from the database, the name of the movie, the genre of, right, movie, duration, and whatever details are there, right? Maybe about the trailer, about the thumbnail of the movie, description, etc. You may get. Correct. So this is what you will get, an array of all these values you will get, which you can display in the UI. What could be the next API?
Theater.
Okay, what is theater? What will be the output and what will be the input?
Input is movie list. Movie.
Okay, okay. And
Data.
date, okay. So what would be the output?
The theaters.
Yes. So yeah, good. Yes. So you can get the theater halls or availability, right? So the way we can design it, like you can have a search API. Search API could be search by theater, right? Or search by city or search by name, right? So basically what this is, the second API could be search theater, right? So in this search theater API, what you may give is, you may give the probably city. So it can give you all the theaters in the city, or you can give movie. So it will give theaters with the city and movie, which you have provided as input, right? So this is a string. Movie could be string, or you may ask movie ID, right? Which is basically you get the movie ID from get movies, which is getting currently paid, right? And then you can search for theater. But yeah, here interesting thing is a theater may be playing a movie. Yes. So see here, this is interesting. Right? So theater, you can say that, okay, this gives an array of theaters. But yes, you have also specified here the movie. In case you don't specify the movie, you may have a theater, say ID1, theater ID1. Then the name of the theater is say PVR. Location, and location could be address, and city could be say Bangalore. Right? And there could be movies playing in the theater. Again, a theater may have multiple movies getting played. Right? Or maybe it has multiple halls. Right? And halls will have multiple movies getting played. So you may design the API like this. This I like because you have the complete details. Or you may need both the API because someone would like to search from the movie. Someone will just want to search the movies. And then from the movie, he would like to search the theater. Right. So better also provide an option to search for movie. So all the theaters have playing that particular movie. Right. So you have to share, you have to give different options to the users based on your requirement. How would you design the interfaces? But the way I would design is, I would say that always the user has to search the hall, right? So I will say search hall. And in this, you may enter city, you may enter date, you may enter movie ID, you may enter, do you search hall? You may, yeah, you may, yeah, you have to, you search hall. You may enter theater, right? Because basically when you search in Book My Show, if suppose there is a UI, sometimes it's good to think about the UI. So in the UI, you will have some search box, right? So in this search box, I may type PVR, and maybe I say Kormangla, right? Like this. What I'm expecting is maybe there are multiple PVRs in Kormangla, right? So could be, so I will get say PVR Forum Mall. And then it has say screen 1 and screen 2, right? And for each screen, the movie also will come. And here, movie 2, movie 3, something like this will I get. And there are if multiple theaters in say PVR, maybe there is another mall, say Ad Mall or whatever name of the mall, I may get that. Here again some screen 1 and movie whatever is getting played here. So basically I'm interested in this movie halls. So you always get the list of halls definitely grouped by theta. Actually, this is grouped by theta. But yes, I may type some string, which is the theta name, but what I am interested is always on the screen. And then I choose this screen or hall. Okay, see here. I need shows, right? For any screen, you will need the shows. So next will be search or get shows. You don't search for shows, you will get the show. And here your input will be hall, right? Hall name is string hall ID or something. So you get the shows then. So yeah, basically, yes, here there would be multiple movie which will be getting played, right? In a particular string. So you don't display this movies. See, when you think from the UI perspective, this is a good way to design the APIs because this is you are thinking about your customer, right? This is also known as design thinking. Now, when you say get shows, you will get the shows. So I say typed. So that means for this particular theater, there may be shows, which is 9 p.m. now. There is a show, movie 1. There could be 11:30 p.m. There is movie 2, right? Something like this you will get. So basically what you get is a show. And then when you select a show, you may have get availability. And in this, you may have to put show ID and you will get seats, right? Array of seats. Great. And then finally, you will need a booking API. Booking API, what will it take as input? Who will tell me? How will you design the booking API?
We will have the booking ID.
What do you need? Booking ID. How can you put booking ID? You don't know. Booking ID. Booking ID will be generated by the backend for you.
So, based on the seat, there is a price, right?
Yes, yes. So basically, when you say booking, booking is your API, right? Or you may call it perform booking, right? You may name whatever you want, maybe just booking. So what you will give is you will give user ID. Who is the user who is doing the booking? You need, right? Then you need to put show ID because you have to do the booking for a show. Again, this is a string. And you have to give seats. This is an array because there may be multiple seats which you want to book, correct? I may want to book 3 seats. So in this case, I will give 3 seat numbers, J1, J2, J3, or whatever. Yes, sometimes there are number 10, 11, 12, based on class, you may have different kind of seat numbers. So you will give the seat numbers and user ID. That means I'm booking 3 seats for this show, and this is the username. Right? What will be the output for this API? When you do the booking, what you are expecting is the details. Your booking status should come. right? Status could be, say, started or pending, right? So you can decide some status. So I would suggest, if I would have to design the status, I will say payment pending and success or confirmed, right? Correct. Or there could be one more status which could be cancelled. Maybe I booked it, confirmed it, and then cancelled it. So basically, this is the states which a booking could be, right? So first state would be payment pending, or you can say it's initiated, booking initiated. Yes, and I would say here payment confirmed, right? And the last one is cancelled, booking cancelled. So payment confirmed, or it's booking confirmed, or payment success. Basically, your booking will be confirmed when the payment is successful, right? So this is the status which you will get, and you will also need a payment API. Right? So in the payment API, what would you need as input? Payments would be, you'll need booking ID.
Booking ID.
Yeah, booking ID, because first you will call, you will get the payment pending status, and you will get other details of the booking, right? You will get the amount in this case. So you have to put the booking ID. Booking ID, you may have to also input the amount, right? And you may have to input the payment method. And yeah, generally we avoid sharing information about credit card, etc. So yeah, you have to, in case you want to share credit card details, etc., account numbers, etc., that has to be shared securely, maybe after encryption, etc. So yeah, you may ask, you may provide credit card details here, which means fields like card number, expiry date, CVV, but you have to ensure this is encrypted so that no one gets to see this detail. And when this method is called, you will get the status, which is payment is successful or payment is invalid, or whatever is the status. Right? So where you will get whether payment is completed, or if payment has failed, you will get the error message. So this is the API design for Book My Show application. Similar API design would also be valid for any other app, which could be booking, hotel booking, flight booking, bus ticket. The searches and the APIs will vary slightly. So you have to share this, right? How, one more API we have to create, which is, once you have booking confirmed, as we said, this is a cancelled status also. You will have an API for cancel booking. In this, you can give just booking ID. No other details need to be provided. And you will get, say, maybe error status, or yeah, there could be an integer returned, which is status of your cancellation, or maybe you can return Boolean, whether the cancellation is successful. If some time limit is there and that has gone past, for example, the show has already begun, then you may say that, okay, no, I'll not allow cancelling of booking. So you may return false. So this is your API design. Correct? So see, we had an application which is a 3-tier application. In Book My Show, what you will have? You will have here a database. So let me draw a database. Yeah, here, this is the database. And you will have here the server. See, here you have many APIs. You may divide these APIs into multiple servers. So how do you divide the APIs? You can divide this by thinking about where you can decouple the system. Because if I have just this architecture that you have here, various UIs, maybe here, Android, iOS, and web, right? These are the UIs, and these are connecting to servers, right? So first problem is if I connect like this, right? I have one server, and then I have a database server, correct? So these are 3 layers. That's why we call it 3-tier architecture. So this is model, data layer. Yeah, you also call this, right? This is the second layer is, this is control layer, right? Or you also say business logic, right? And then finally, you will have the presentation logic or UI layer. So this is the 3-layer architecture, also known as view, model view controller. Now, what could be the problem in this architecture? Tell me one by one. You have thousands of movies which are getting played. Our application is a global app. Search may be slow.
And the fault tolerance.
Repeat.
Fault tolerance.
Fault tolerance, right? Yeah, you have a single point of failure. Where is the single point of failure? Which is also known as SPOF. Yes, single point of failure. So where is the single point of failure?
Or 2 places,
Yes,
business layer and data.
right? So let me remove this by having multiple servers. Right, so I may put multiple server instances. Yes, so and then instead of calling directly, I may put a load balancer. Right, so load balancer. Let me introduce a load balancer here. So let me use this as a separate diagram rather than modifying this. Right, so what I'll do is, these are my APIs, and let me draw separately this. Right, so yeah. So one way to reduce single point of failure is I will introduce a load balancer. Right, so let the UI call load balancer, and let's have multiple servers. Let's say there will be multiple, right? So like this, server 1, so 1, server 2, and 3, right? So just I remove here. Yeah, you understand that these are multiple servers. So instead of connecting directly to the server, I connect to the, this, and then servers will make a call to the database. Right, so basically I will have an architecture like this, and keep it like this. So schemas. So basically I have introduced one more layer, which is the database. So this is gone here, right? Now, single point of failure is gone. Or not gone. What do you think?
Database layer.
Yeah, the database is there, but what about the server? Is there still a problem in some server layer? There is still, because a single server may contain all the APIs, which is cancel booking, payment, perform booking, get shows, search, theater, etc. So there may be, if some crash happens, the entire server will be down. But yeah, you have other servers, so your load balancer will redirect to other servers. But yes, still you have a database as a single point of failure. So what can we do to reduce single point of failure in database?
Can we use master slave architecture? Different.
Absolutely right. Right. Correct. So you can use a master slave architecture. So what does it mean is that you have various databases. So let me say this is slaves. And is this a read heavy database or write heavy database? What kind of application is it? Is it read heavy or write heavy?
Read heavy.
Right, because your movies may be changing once in a week. Right? Theater details, show timings, etc. will be changing once in a week per theater. But yes, you see here, the availability will also be changing frequently. Maybe the ticket booking will be changing here. So you may have a lot of writes also, but still reads will be much more. Because searches for the movie will be more, booking will be lesser. Correct? Maybe 10 people will search. They may find an interesting movie in interesting time, or they may not find the ticket also availability. But yes, more reads will be there. So this is read heavy. And you would need, so this is master. Green color is the master database. And from master, you should have the replications to all other systems. So if you have 3, and read can happen from any of these servers. So server can read from any of the slaves. To simplify this, always good practice. See, I'm also, way I'm drawing, you should also try to copy and present your diagram in the interview like this, right? So rather than just showing 3 different arrows, I can do like this, right? That means server is connecting to any of the databases. And write, this will be write. And this is read. Right? So now there is no single point of failure for read. For write, also there is no single point failure. In case this database fails, you will upgrade this, any of the slave. If master fails, then you will upgrade any of the slave database to master. So this is how you will reduce the single point of failure. Correct?
So when write happens, it will immediately sync the data to slave database.
If write happens, your write will happen here, and then it will be replicated to slave databases. Right?
Immediately or
In the
sync will happen immediately or after some time?
Yeah, sync will happen it could happen immediately, or it could happen after some time. See, always there is a time required to sync. Yes. If you're syncing immediately, that means you will be syncing small information, right? At a time. So sync will be faster. But the load on the database will be higher, because if every minute 10 or every second thousands of requests are getting right, you will have a lot of read-write replication going on. Your performance may become very slow in the master, because replication is also an expensive process. You may also wait for some time and then sync it. But in that case, what is the problem? If you wait for some time, you may have dirty reads. You may read something which has been changed. Correct? But yes, you have to take care of this scenario of having optimal load and also data recency, data consistency. Generally, what is preferred is you wait for some number of writes and then sync in bulk, right? So this way you can avoid load on the database. But yes, there are very complex products available which can do efficient replication. So good databases like Oracle Enterprise Edition, they will be doing sync in a very efficient manner. So that will be inbuilt capability. There are also third-party products which will do the sync. You should also understand that these slaves may be located near to master, or they may be available remotely also, right? So, but yes, these are various considerations which you have to take care. What else? What could be the further problem in the database? If your data is too much, you have many movies, search may be slow. So do introduce a caching layer. Right. So let me add a caching. So let's say, where is the cache? Yes, some kind of cache I will introduce. Yes. So let me get a cache. Yeah, I got this. Yes. So now I got the cache. So here my cache is this one, right? So this is the caching layer. So you never read, you read first from the cache. And if data is not available in the cache, then you connect to the database. And this is about caching. Right. I have not put any cache in the right. Reason? Looks
The
good.
read will be to the slaves.
Yes, you will read and you want performance in the read. Write is you will anyway, you will do directly to the database. But the problem, there is a problem. You're writing to the database and data will change, your cache will be invalid. Yes, because cache will contain old data. You're not updating the data. Assume I have a movie here, movie X. Right. So assume this movie has been updated. Now there is a new movie which has been put on a particular hall. Now this movie Y has come. There's no way the cache can be updated here. But how this will happen is, see, I'm updating the master. Master will update the database, which are the slaves. So there should be a mechanism where database can update the cache. Right? So basically what the way it works is, one mechanism could be you have the expiry date for this cache, right? Which could be, say, 1 minute or 1 hour. Let's take it 1 hour. So after 1 hour, we will delete this. And we may have a scenario where you have least, or sir, yeah, you may have LRU cache, least recently used cache. So what will happen? After 1 hour, the movie will be expired. So cache will be refreshed and the data is not there. So it will be reading from the database directly. And since it's being read, it will update with movie Y. Right? So this is one way of how the cache could be invalidated and updated. Still, there could be problem. Assume we have this application in all the geographies, right? Say we have India, Pakistan, Nepal, Bangladesh, Russia, US, China, everywhere. We are allowing Book My Show to book the movie tickets. So that means your database table will become very large. How can you deal with that?
Sorry.
Right. So yes, you can apply sharding. Right. Or sharding was also known as partitioning. Database partitioning. Right.
So for one location, we are giving a database. Is that correct?
Yes, yes, right. So you can shard based on various properties. And one of the common use cases, just a minute, let me get, there was a very nice diagram about sharding, which will give you good idea about what is sharding. So just a minute, let me get that. That yes, it should be here. So I think now it should be there. What happened?
Sir, I have a question in caching.
Pardon?
I have a question in caching.
Okay, go ahead.
The cache will be in the same server or different server?
Yes, cache will be in a separate server. Right? Cache will be in separate server than the backend server. Yes. Now I think I have got sharding. Yeah, I got that sharding. So this, I will do the sharding. Yeah. Cache will be a separate server altogether. So cache becomes again a single point of failure. Yes. But you can have multiple replications of the cache. Yeah, right. See, cache will also become single point of failure. But yes, you have multiple caches here. This is basically in-memory cache. So you have multiple in-memory cache. This way you will be, if one cache goes down, you have other copies. Now sharding is storing information. Maybe you can distribute the information in such a way. Assume you have information for all the countries. And if you have only 3 shards, you can say, okay, all the countries is starting from A to I. I'll put in shard 1. All countries is starting with the name J to R. Will in shard 2, and so on. Right? This is one strategy which you may allow. Basically, you need a hash function which can determine to which data you should store the value. So this way you have multiple small databases with less number of rows. This will improve the performance. So this is all about sharding. Right? In this scenario, you will either book for India or US. You will not book ticket in India and in US at the same day, because travel time is too much, right? So there is no possibility that on the same day you may watch a movie in India and then you watch a movie in US. So you can split the information in different shards. So for user, you will have all the information in one database, right? Which is, if a user in Indian, he will have all the information in India shard. If a user is American, he will have all the information in US shard. There is no possibility that a same user will have to can book in India and in other country, right? If he books, yeah, he may book after some days, maybe 2 days or 1 day. But yeah, there is possibility that I may watch one movie in the morning in Bangalore, one movie in the evening in Hyderabad, right? If I am a movie buff, right? So I may watch 2 movies on the same day and I may travel across the city with flights, because 2-3 hours I can travel from one city to other city.
And he may book for others.
Pardon?
He may book for others.
Yeah, he may book for others, but yes, that is also possible. Yeah, correct. Yeah, absolutely right scenario. So this is another thing which you can do in sharding, right? So shard the information. So basically to partition the database. And your application will be aware of which shard. So if the booking is in US, it will redirect to the US database. If India, it's India, because you have this logic, mapping logic to move to request the appropriate database. So this is, I think, yeah, this is for if maybe if there is some booking in Pakistan, right? Then yeah, this shard will be used. If there is a booking in India, this shard will be used. If there is a booking in, say, US, right, this shard will be used. And maybe let me Russia. So something like this could happen, because your server can decide where this server knows. It needs to be aware of what shard contain which information so that it can request the right server. Right? Again, you have in this servers, again, master slave configuration. Basically, everything is here, but in different locations. Yeah, you may keep these in different locations. Maybe India server is in India, Bangalore, Mumbai, Russia could, yeah, this one could be in Europe. You may put these in different locations also. So you have to decide what could be the strategy for sharding. So you have to come up with the strategy for sharding. There could be many strategies based on user ID or based on the country of booking, based on the movie theater, or maybe based on the movie. In Facebook, you need a lot of shards because Facebook is running on MySQL database. And initially it used to have various shards. It manages billions of users using shards. And shards are designed based on various algorithms, and they are also based on geographies. Twitter also uses sharding. So this is all about databases challenges. Another challenge is still there, that maybe you have 1,000 requests per second for searching. Let's talk like this. Maybe not 1,000 would be less. For an application like Book My Show, there may be 100,000 requests. I would put 100K request per second for searching a movie, right? There is a popular movie, but maybe seat booking is 10K request per second, right? This is booking. So the problem here is, if you have both the searching service and booking service, then you have to scale it to meet the requirement of 100K request per second. So let's assume we have a CPU. This is a CPU. Let me get the CPU. Yeah, I have the exact CPU diagram also. So let's say I have a CPU. Okay. This is my server, right? So this is the CPU. Yeah, it looks, it's a mobile, but yeah, let me call it a CPU. This CPU can take, say, 10K request per second. So if I have to have a search service, this one, first one, definitely I will need 10 such CPUs, right? So I'll need 10 such, right? Correct. Or let's say this is 50K. Yeah, drawing 10 is difficult, so, or time consuming. So that's why for simplicity, I'm writing. But booking is only done with 10K. So what if I just deploy searching service here, and I'll have one more server, which is having the booking service. So this way, I'll be able to scale different services separately, right? So that's the advantage. That's another advantage of breaking the architecture into different components, right? So my server layer, I could break it up into 2 parts so that I don't have to keep 10 servers for booking or 5 servers for booking, because one server is good enough for taking care of 10K request. So one server will good. So this is the advantage of microservices architecture. You can scale up and down one particular service and without impacting the other service, right? And even complicated scenario could be there, that only over the weekends I got 50K request. Other time I get only 20K request for searching. And booking is maybe 10K, and yeah, always 10K. It could be the case that, but yes, search increases if some new movie is released, but booking will always be constant because your seats or number of theaters, number of shows are almost same. So in that case, I can scale an up and down the search service, but I need not have to worry about scaling up and down booking. So I can scale services independently. This is the advantage of microservices architecture. Other advantage is I can release the updates individually. When I update booking service, I do a bug fix or I do an enhancement in booking service, I need not have to update the searching service. In this case, maybe I will like to introduce new feature in searching. But booking, I may keep it stable because this is my revenue generating portion. This is my user experience improving portion or component. So maybe I will be doing frequent updates in searching, but not that frequent updates in booking. This is only possible if I have isolated servers, which is also possible in microservices architecture. So this is about microservices architecture. So you can implement this service also as a microservices, right? So I may have a booking service, which is a separate service, searching service, which is a separate service, which could be for searching movies, theaters, shows, right, etc., whatever. And booking service could be for booking and maybe for payment. It may take payment or I may isolate the payment service also. Generally, payment is taken care by the third parties, right? You will integrate with some payment gateway, which could be UPI or MasterCard or some other payment gateway, which could be Razorpay or any other payment gateway, PayPal, etc. Stripe. These are some examples of payment gateways. So yeah, you may have multiple microservices which will be running the backend logic. So this way you will also reduce single point of failure in the server, because if your search service goes down, you still will be able to support the booking. Maybe your search will be slow or search will not be possible, but if someone knows the show where it is, he may choose the show and book the ticket directly. But that means he has already searched, but then the search goes down. But yeah, since he has got the list of shows, he will be able to book the ticket. So this is another benefit of microservices architecture. So there are various benefits and disadvantages of microservice. We will discuss this in detail, but today I just want to introduce this. And this could be used in the server layer. This will reduce single point of failure from the server layer. Right? So we have clustering at the server level, which is also known as horizontal scaling. This is horizontal scaling. And other approach could have been, you would have said, why not you buy one more expensive hardware instead of putting 5 servers. Right? But then that's a problem, because if again few more requests come, you have to buy another one. And there is a limit to how big a server you can buy. You will always reach a limit, and then you have to scale horizontally. And it turns out that multiple small servers are less expensive than one big server. And if you have a big server, again, you have the problem of single point of failure. Now, at least if one server goes, you have 4 other servers, which will still be able to serve. Your performance is degraded, but still you will be able to get the response. Right? So this is another way of controlling or making the application fault tolerant or reliable. Now there is one more place where you have single point of failure, which is the load balancer.
Yes, we need to have multiple load balancers, right?
Right? You don't have multiple. but you can have two, which is basically active passive. So there are two configurations of load balancer. One is active active, other one is active passive. And load balancer just do very less work. It's just routing the call. So it is not an intelligent piece of software. It is just taking a note of how many servers are there and what is their response time. And based on some criteria, which could be round robin or which could be least response time, or it could be weighted round robin, it will be assigning the traffic to the appropriate server. So you may have one server which is active, other one could be passive. So let me say this is my, if one goes down, then you have the other one, right? In active passive, you always serve the traffic using active load balancer. And once active goes down, you switch the load balancer automatically to the passive becomes active one. So you have a backup. But then there would be one other possibility. You may say, I will use active configuration where I will be using both the load balancers all the time. If one goes down, then I will have always relying on a single one. Otherwise, I will use both of them. So if both this configuration is valid, you assume that only one load balancer will go down at a time, and then you can switch to the other one in case one becomes inactive, and you can repair it. And by the time you repair it, your other load balancer is serving, and then you can switch it back. So this is how you will reduce single point of failure in load balancers, right? So this is now very reliable application because we have removed the single point of failure in all the layers. Right? Any questions, queries? So Suresh, clear? We discussed normalization in detail. We discussed various system components like database. We discussed caching. We discussed sharding and microservices architecture. And when we'll be exploring more data, more applications, in the next class, let's discuss some more applications. So what I will be covering would be in the next class. Let's do a system design of payment gateway, right? This we can cover, which could be UPI, GPay, or PhonePe, or yeah, anything similar. And this is what we will cover in the next session. This payment API is not that database heavy application, but it is important because you need best performance here. So it is complex in the sense that you have to scale it. Say, for example, yeah, Paytm is another example. The volume of transactions which these API gateway is serving is in billions of transactions per month. Multiple millions of transactions per day. But still, when you do, you get the payment instantly. And there are so many competitors. If some starts performing slow, you will immediately switch to the other one, right? If Paytm is slow, you will switch to GPay. GPay is slow, you will switch to PhonePe. If performance is not good, the application will lose users and it will run out of business. So this is something we will discuss in the next session. And then definitely while discussing all these, we will be discussing associated concepts. And this will be high level design of payment gateway.
So Tarun,
Yes.
so can I say microservice like in this way? Please correct me if I'm wrong. So as you draw some CPU diagrams here, searching movies, theaters, and shows. So basically they changes. So that's why we took more CPUs, but whereas booking, the process is same for all. So that's why we took one CPU. Is that correct?
See, searching you will do more often. Many users will be searching for movies.
Yes.
Finally, one will be booking. Yeah, right. So maybe you will also search 10 times and then finally decide, yeah, this is good and I will go for the booking. So that's why booking you will do less. In a system, booking transactions will be less, search transactions will be always more. That's why I have more CPUs in the search.
Okay.
Right?
Okay, got it.
Right. So that was the reason why I drew like this. Correct. It could be 10:1, 1:5, or whatever. But yes, you will have some ratio. Definitely. So just for indicative purpose, I used 5 servers, 1 server here. Right. So as an engineer, you don't have to worry about, you just have to say this design could be done this way. And there is some assumption that means 5 times it is. Searching is done 5 times more than booking. Great. So yeah, we'll be covering microservices architecture in more detail. So definitely I've just touched upon sharding, also some of the fundamental concept, but I will be deep diving in later sections, right? We'll be using it. But yes, as of now, you should just be aware that yes, this is microservices architecture, this is sharding, this is caching, this is load balancing, etc. Right? But yes, as we will move on to more complex system, I will be introducing in more detail the same concepts, as well as I will be introducing new concepts as well. So keep attending all my sessions, and this way you will become very proficient in system design, because in Book My Show, why I'm covering payment next is because in Book My Show, we have not handled the payment. Payment is also a crucial part of any application, whether it's a e-commerce application or a booking application or a flight booking application or any kind of booking application. Payment is always important. So we'll have to deal with payment gateway. So we'll do that next. And then if you are asked questions about Book My Show, you may also share the details of the payment module. We will also cover searching also. I will also cover a design of search engine, which will be next than this. So you will be able to even design a search engine, because search engines are again important, because for movie booking also, you may have search, because here we have used database search. Database search is good if you're searching on exact field match. But assume you have a lot of description and you are searching on the description of a movie, or if you have many actors and you are just searching in some characters, then it may become difficult for database to handle such queries. right? So then we'll discuss how to build search engines, and search engine generally we will be discussing Elasticsearch as the search engine. So we'll cover that in the next week. So probably, yeah, this is the curriculum for the next week, which is in depth about payment gateway, in depth about search engine. And this will also cover in-depth concepts like microservices, REST APIs, and sharding, replication, right? All these things we will discuss. And then after this, we'll discuss message queues or how to do asynchronous processing, right? So, which is designing using Kafka. I'll also cover how to apply Kafka into the designs. So this will give you very good understanding of how to build complex systems. Great. So see you in the next class. Have a nice evening. Good night.
Good night, Tarun. Have a great weekend.
Thank you.
Yeah, same.
Yes, yes.
Bye. Same to you.